Even we are finding it difficult at ISRO to stick to our schedules because of the same COVID-related issues.
Same. Very well.
Lot of restrictions. We're finding it difficult.
Do you want sir to exit the screen, and do you have anything to show, or is it fine? Hello?
Hello?
Yeah.
Hello?
Hello?
Yeah, Divakar sir, we can make it stop screen.
Stop screen, stop share or something?
Yeah.
Stop share. Yes.
Then I can again enable, right?
Okay. Yeah.
Okay.
Yeah, perfect now. Some interesting things must be happening at ISRO, right?
Yeah, actually, that is one new thing which we have got into, where there is a policy change from the government, where we are trying to encourage startups and industries to participate with ISRO in its activity.
Okay.
Up in a big way, and then we are encouraging a lot of new proposals. People can participate with us in our programs.
Yeah.
This is happening now, and that's an interesting opening for the user community and also the academia, if they want to perform something unique which matches with our program schedules and matches with our objectives.
Correct.
In the launch vehicle, in the satellites, as well as in the applications area. So that's encouraging a lot of people to participate. I expect many things to happen now, particularly the youngsters who get into startups.
Your video just during when you introduce, it will be good. You can have your video also so that people know you are introducing. Huh? Okay, sure. Thanks. I think still we have another 2 minutes. Yeah, sure. Yeah, thanks.
And also we are looking at new policies now. We are trying to rewrite the policies with respect to SATCOM policy. Now satellite navigation is also there, and we are also trying to improve upon the remote sensing data policy and things like that. So we are trying to make it more open so that more academia can participate. They can download free data and start using it for various developmental activities. Or possibly addressing some of these things when I talk. So things are happening now in a slightly different way. So no new verticals are coming up in ISRO. Enable all these activities to happen.
Correct. I think it's very good. There is a good opportunity for people to work on.
Yeah, exactly. In the sense, academia can directly work with ISRO in research areas. That's going to be an interesting thing. So if you have any startups that you are linked with from DSU, they can directly send a proposal to ISRO now. I can guide them on that.
Yes, sir.
So how's your schedule, sir, every day?
Yeah, I come to the office around 8:45 to 9.
Okay.
It will go on up to 5 o'clock in the office.
Oh, okay.
Then I'll go back home, and normally there'll be at least 1 or 2 meetings between 7 and 9.
Okay. Yeah.
And 9 to 9:30 normally watch that IPL or whatever.
Just a change. That's it.
Yeah. Otherwise, I go mad.
Yeah, really, absolutely. That is true.
Madam, can we start 9:30 sharp? Rupashri, madam.
Yes, sir.
Yeah.
A very good morning to one and all gathered here. On behalf of Dayananda Sagar University, I, Professor Rupashri S., Assistant Professor, Department of Computer Science and Engineering, Dayananda Sagar University, welcome one and all gathered for today's guest lecture arranged in association with BITES. A warm welcome to our distinguished speaker, Dr. P.G. Divakar, former Scientific Secretary and outstanding scientist, ISRO, Bengaluru. A cordial welcome to our Excellency, Dr. K.N.B. Murthy, Vice Chancellor, Dayananda Sagar University, Dr. A. Srinivas, Dean, School of Engineering, Dayananda Sagar University, Shri M.N. Vidyashankar, Co-Chairman, BITES, and our most valued invited guests and participants. Thank you for taking time out and being here today. Today's talk concentrates on Indian Earth observation satellites and their applications by Dr. P.G. Divakar. Before we start, kindly note, if you have any questions during the presentation, just type them into the Zoom chat box. We will be available to post your queries to the speaker during the QA session planned at the end. A brief introduction of today's eminent speaker, Dr. P.G. Divakar, former Scientific Secretary and outstanding scientist, ISRO, Bengaluru. Dr. P.G. Divakar is currently an honorary distinguished professor, ISRO headquarters, and served ISRO as scientist for the past 36 years. He obtained his PhD in Participatory Geomatics from NITK Surathkal. Dr. P.G. Divakar held important leadership positions in ISRO, such as Regional Remote Sensing Center, Bengaluru, Associate Director, Earth Observation System, ISRO Headquarters, Bengaluru, Program Director, Earth Observation Systems and DMS, ISRO Headquarters, Bengaluru, Deputy Director, National Remote Sensing Center, Hyderabad, Scientific Secretary, ISRO, and presently Director in Earth Observation and Disaster Management, ISRO Headquarters. Dr. P.G. Divakar served on the Committee of Earth Observation Satellites, CEOS, International Charter, Space and Major Disasters, and UN Economic and Social Commission for Asia and the Pacific for more than a decade. He has been a recipient of several awards and recognitions, such as National Gold Award for Innovative Usage of Technology and E-Governance, Globe Sustainability Research Award 2010, Stockholm, Sweden, ISRO Merit Award for Innovative Use of Space Technology, National Geospatial Award, Indian Society of Geomatics, ISRO ASI Award for Space Science and Applications, Bhaskara Award 2018, Indian Society of Remote Sensing, ISRO Team Excellence Awards for 4 major national application missions of ISRO, Aeronautically Society of India ASI Award for development of Bhuvan Geoportal and Geospatial Excellence Award, Kuala Lumpur, Malaysia. He has been conferred the Fellow of Indian Society of Remote Sensing and Distinguished Alumnus of NITK Surathkal. He has authored more than 75 publications in national and international journals. A very warm welcome to you, sir. And I now request Dr. P.G. Divakar, sir, to take over the session.
Thank you very much.
Stop the.
Yeah. India,
Yes.
please stop.
Yeah. Divakar, you can take over now.
Yeah, my slides I need to uplink, right?
Yeah. Again, share screen kind of thing.
Is that okay?
Yeah, perfect.
Yeah, okay. Thank you very much to Professor Murthy for getting me onto this presentation. And I would like to thank you very much also for a nice introduction. I think maybe it could have been a little bit less. You got into the details of various things, but yes, as was told in the beginning, I will be talking about Indian Earth observation satellites and the various applications what we normally deal with. And thanks to Bytes and DSU for getting me into this. Sorry, the screen is not changing. So
you have to use your this one.
Okay.
Yeah.
Everybody knows ISRO very well with respect to its rockets and satellites. That's what everybody sees it on the media. Like we have more than 185 missions. In fact, 186 successful missions, where about 77 launch vehicle missions and 109 satellite missions have been successfully done. And we have varieties of rockets that you keep seeing on the media. It could be the PSLV and GSLV, even though we started off with SLV and ASLV kind of launch vehicles. And of course, we are getting into different types of launch vehicles in the near future. These successful launches have given us a lot of confidence in the launch vehicle technology, including the completely indigenous PSLV, and also getting into the cryogenics, which has been very, very successful for the GSLV kind of launches. On the satellite front, which I will be concentrating more today, we have remote sensing, communication, navigation, as well as space science missions, and we have very good accomplishments in all the four areas. While we have been doing pretty well on the satellite front, we have also been doing a lot of new experiments with respect to space capsule recovery experiments. It could be even crew module recovery, which we quite recently have done, and also looking at new ways in which reusable launch vehicles can be demonstrated. You will be very soon seeing one more RLV technology demonstration very soon. And of course, the scramjet engine and various other things, including the crew escape system, which was also demonstrated. So these are sort of experimental missions which we have been conducting. Of course, considering that ISRO is going to get into Gaganyaan related activities, we need these kind of technologies to be developed and demonstrated so that we are successful in Gaganyaan kind of missions. While doing these for India and trying to develop these technologies, we have also been successful in putting 319 satellites of 33 countries into space. This is another unique accomplishment as far as India is concerned. Just to introduce some of the different types of satellite systems, what we have in addition to the communication satellites, we do have our own constellation of navigation satellites. Something like the GPS, what we talk about, we have it for a regional system. That means for the Indian region, we have our own navigation system, which is made of the IRNSS series of satellites. We have about 8 satellites in space that provides 24/7 location information, and it covers about 1,500 kilometers from the Indian region on either side. So it's quite a huge area that we are able to give the location-based inputs. It could be used for wide varieties of activities, which I will not be concentrating on that today. In fact, that could be a separate talk, ideally speaking. It requires a lot of ground equipments, which you are able to see on the right-hand bottom, wherein it is possible for you to use it for ground surveys, it is possible for you to use it for mobile applications and various other activities. On the space science and satellite planetary missions, ISRO has been doing pretty well, and everybody in the country is aware today the kind of success we had in Chandrayaan-1, which was the first mission to the moon. Subsequently, we were possibly breaking records when we went into the Mars Orbiter mission, which was a unique success as far as India is concerned. And of course, the Astrosat, which is already serving the country and the global community in a big way, particularly by giving an access to a space observatory system, which enables you to look at the space, look at the galaxies, and look at the nuances of space and its activities in a big way. So these are some very unique contributions. In addition to that, we of course had Chandrayaan-2 mission, which gave us an enormous amount of success with respect to the orbiter, and also a great experiment for us to even try to land on the moon. The world has witnessed that pretty well, and we have been having very good outputs and outcomes from Chandrayaan missions, both 1 and 2. As you very well know that the Chandrayaan-1 proved that water is available on the moon, which has enabled a lot of people to go back to moon for exploring more and more. A typical example of a crater on the moon. And on the Mars front, this is a typical example of how the global albedo can be mapped onto the Mars. And this is a very unique thing what you are able to see. On the Astrosat front, you are seeing a picture on the right-hand side, which gives you a clear example of the kind of observations we are able to do it in the galaxies. And of course, on the Mars mission, a lot more things are happening. In fact, some of these things can be downloaded online through ISRO portals. We can give ideas on how to do it, both on the Mars and Moon missions we have put out on the public domain. But today my focus is on the Earth observation satellite. So I thought I'll concentrate more on this. There could be separate talks on space science and also on the navigation and communication system, because each one is a huge chapter on its own. Earth observation basically gets categorized with respect to land and water, basically to do the various activities with respect to the Earth. We have a ResourceSat series of satellites that provides us the kind of data in the optical domain. We have high resolution imaging satellites wherein Cartosat 2E and Cartosat 3 gives you a centimeter level of imaging capability. While we look at the land and water and also high resolution imaging for mapping, we also have dedicated missions for ocean, because ocean is a different characteristic altogether when we are looking at ocean. So we have OceanSat series of satellites, as you see here, and also some interesting missions we launched with the French Space Agency. We do a lot of collaborative launches. One of those is this, the SARAL, which basically does the measurement of altitude. Basically, altimeter is the particular instrument which is of interest here, which provides us the wave heights, while scatterometer gives us the wind velocity and direction. So put together, the OceanSat, the SARAL, and the SCATSat gives you varieties of vital parameters with respect to the ocean, wherein OceanSat 2 or even OceanSat 3, which we are going to launch very soon, provides us the ocean color information, which is helpful for understanding the ocean productivity in the form of chlorophyll and food production, which automatically leads us into fish catch. And that's the beauty of using OceanSat 2 data, while scatterometer and SARAL gives us the other parameters that is useful for understanding ocean and use it for varieties of developmental purposes. On the weather and climate front, we have INSAT series of satellites. These are different kinds of satellites. They are put at 36,000 kilometer orbit, that is geostationary orbit, while all these satellites which you are seeing are polar orbits in nature, wherein they go from pole to pole, varying from 600 to 900 kilometers. So there are different categories of satellites and different nature of working mechanism of these satellites, which provides you wide varieties of views of the Earth, what you see on the down below. Of course, I have not put out the microwave remote sensing satellites. We will be launching a few very soon, in addition to the OceanSat 3, what I talked about. So we will be seeing some very interesting advanced missions very soon. But my focus now will be to see how these satellites are used by India and for developmental purposes, which the country has to use because it has rich dividends from space. When we are talking about Earth observation satellites, we also need to know what kind of mechanisms we use for imaging the Earth from space. So we use the push broom technology for the cameras to be used with the detectors, so that you will be able to get a good set of images from space. We started off in 1988 itself when we started using the push broom cameras. We also have developed the stereo imaging capabilities much earlier. Cartosat 1, which lived for about almost 13 years, was able to provide fantastic pictures of the Earth, particularly Himalayan region. As you see on the left bottom, you can visualize the terrain in the three-dimensional mode because it gives you the 3D views in the form of stereo imaging capability. When you get into the ResourceSat kind of a system, it is a three-tier imaging capability wherein you have a coarse resolution, high swath, large swath imaging, like 740 kilometers can be seen in one go, while you have two other cameras which measures about 141 kilometers and 70 kilometers. But the 70 kilometer swath imaging capability will have 5.8 meter resolution. So it's a very high resolution, smaller swath, and a very large swath, medium resolution. Both these kind of cameras with an in-between resolution is kept. So it's a very unique imaging capability what India has built, and it's a heavily sought after satellite by the global community, particularly the Brazil and US has a rich use of this particular satellite for their own country and purposes. But of course, I will be showcasing to you how India uses these satellites for varieties of activities. The other interesting imaging capability which India developed was for the radar imaging capability, synthetic aperture radar, wherein it is supposed to be all-weather imaging capability. When you say all-weather imaging capability, you can do the imaging in the night, in the day, in the evening, anytime you can do. Clouds will not come in the way because we are talking about radar, which is much different from the optical imaging capability like what we saw with respect to the optical imaging sensors. So India has developed radar imaging capability as well as the optical imaging capability matching to anybody else in the world today. And we have excellent examples of using it for countries' developmental purposes. We have not stopped at that. We have also got into the hyperspectral imaging capability, wherein hundreds of imaging modes are there, in the sense the same red, green, blue can be split into smaller sections, and we make it into something like 256 bands imaging in the optical region. And this allows you to see vital information which otherwise is not possible. Hyperspectral imaging allows you to see better discrimination of rock types, better discrimination of agriculture and vegetation, and it springs up a lot of new spectral imaging and spectral data processing capability which ISRO has been trying to master. We have a very interesting hyperspectral imaging capability in space which provides vital information with respect to the natural resources. Of course, we will be seeing more of hyperspectral imaging in the near future. HISIS is the satellite which is providing such kind of images. You can see the kind of the spectral curves that is shown here, and also the imaging capability, wherein it becomes an image cube. It's no longer an image of 2-dimension or a 3-dimension. It is an image cube which has multiple bands for every pixel. That's very, very unique. Now let's get into actual orbit. When we are putting our satellites into the orbit, we start looking down on the Earth from different parts, different positions in space. As you know, Earth is a moving object. You can see it from this particular slide also, that the Earth is a moving object and satellite is also a moving object. The polar orbiting satellites, as it is being demonstrated here, goes from pole to pole, goes around the Earth, while the Earth is moving from west to east. So there are two moving objects here. The Earth is moving, the satellites are moving, but still we make very high resolution, accurate imaging of the Earth and use it for developmental purposes. So let us look at the various applications that we do from these satellites. Before we get into that, I thought I'll just show you the kind of images that we get from space. Imaging capability of India is something phenomenal, because you are able to see the kind of resolutions. With the data fusion, we are able to, this is basically after processing the data, you are able to get very high resolution, accurate imaging capability. You are able to literally visualize different terrains at very high resolution. And on the bottom right, you are able to visualize the height of the terrain very accurately with the ResourceSat and Cartosat kind of satellites. While doing so, you are also able to see the Accelerometer data, as I was talking about the vectors. The wind vectors gives you a lot of information about ocean. See, ocean almost consists of 70% of the globe, so understanding ocean is more important. So we have a very interesting satellite, Accelerometer, which provides a SCATSat, which provides a vital information with respect to wind speed, wind direction, and things like that. Of course, atmosphere comes in the way. We try to do atmospheric correction. At the same time, right-hand side bottom, you are able to see an animation of the cube of the hyperspectral, which I talked about some time back. I just thought I can show you the dimensions of imaging, the dimensions of the data processing capabilities, which one need to have. You are able to produce that kind of satellites, but when it starts beaming the images down onto the Earth, you need to have that kind of data centers, capabilities, processing tools and techniques, which you need to develop and demonstrate, which ISRO is able to do it quite successfully. But there are a lot more things to be done, which I'm sure academia will be able to chip in a very big way to work with ISRO in the future. Our satellites also visit North Pole and South Pole, where we talk about the dynamics of ice in both Antarctica as well as Arctic, and we do continuous imaging of both North Pole and South Pole, and keep observing and making observations with respect to the status of the ice, which is very, very important for climate-related activities on the Earth. I'm showing you a picture of Himalayas, and I'm just going to demonstrate to you something very interesting, which is called as digital elevation model, and how one can analyze a digital elevation model, particularly from the terrain perspective. This is taken from Cartosat 1. What you're seeing is actually the Everest, the Mount Everest. You are able to actually see the peak of the Mount Everest here. And suppose this particular data, this is a 2D image. Suppose this particular data is taken in 3D and it is visualized on the on your computers, or if you want to simulate a fly through a particular terrain of Himalayas, it is possible for you to do it quite successfully. And you can actually see in front of you that this is the Mount Everest. This is the peak of the Mount Everest, which I was showing you in the previous slide. This is basically a data that has been processed in our data center after actually capturing a stereo image. And this gives us a different perspective altogether when you start analyzing satellite data. And that's what I was trying to highlight here. Cartosat Stereo provides a very interesting imaging capability, which allows you to see not only 2 dimensions, but also get into the 3rd dimension, and you can start analyzing the height of the terrain in addition to the pixel value and the pixel position. So we will be, in fact, a lot of additional parameters are possible when you have this kind of data, because it gives you a new dimension altogether. You can start analyzing the landslides that happen in the high reaches of Himalayas. And you are able to actually pinpoint on the landslides area. This is a typical drainage which is passing through the Himalayan inaccessible area. When the actual landslide happens, it is possible for you to visualize the amount of dump that has come down from the top. You can see that, and it is resulting in a huge amount of waterlogging. You can easily analyze such data. Not only that, you can start quantifying that. How do you quantify? The dump area can be calculated, the volume of dump can be calculated, the volume of water stagnant can be calculated. It has affected the flow, which can create a lot of problem on the other side. Suppose you remove the flow, it can also create a problem on the other side. Transboundary disaster is what we talk about. We do quantitative analysis from such images because it gives you 3D, it gives you the contour data, and it gives you the pixel values down on the ground. So we do the quantitative analysis before we enable the water to flow back in the particular path, the way it is supposed to do. So this kind of analysis is possible from space because of stereo data. Now let us move into the other sector. I was talking about wide field sensor, which covers 750 kilometers swath. It can actually cover the entire country of India in 5 days. As you know, the stretch of the country, length and breadth wise, is something like 3,000 kilometers as far as India is concerned, roughly. So if you are having a 740 kilometer swath, in about 5 days, you can cover the entire area. The kind of resolution, in fact, you can see the Himalayan terrain here. This is the other side of the border. You can see the Brahmaputra. You can see the Sundarbans. For example, I can click into the Sundarbans. You can start looking at the mangrove forest in the Sundarbans. You can start analyzing the spectral response of the mangroves, and you can start analyzing the total area of active mangroves that is protecting us from the environmental point of view in the Sundarbans region. We can start analyzing such data. That's the beauty of this. But we just don't stop at just looking at Sundarbans. We look at the entire country on a regular basis. How do you look at the entire country? Here is an example. Every year, we do the land use land cover mapping of the whole country. We also look at those land parcels that are not used, or we call it as wastelands, and how that can be brought into productive use. This kind of data, we have been doing it. In fact, last 15 years, we have land use land cover maps. One can go back to something like 2003, 2004. How was our land use? And you can come back and see how we have changed or conserved our forests, conserved our natural resources, and literally the entire country's land use land cover. For example, the cold desert or the Himalayan region, you can see here, this is the vegetation patch of the Himalayan region. This is the northeastern Himalayan region, where it gives you lush green, excellent vegetation. The Rajasthan deserts, the Gujarat area, and of course the Western Ghats. You can see very clearly each patch of those. Of course, you can get into state-wise analysis, and you can start doing time series analysis and things like that. Not only that, since we do seasonal data, this is a very unique data what we do. AWIPS, as I told you, covers the entire country every 5 days. So we can literally see India every 5 days. So if you are able to see India every 5 days, you can imagine how many times we can see India in the entire year. We are talking about 12 months into something like 5 days in a week. That means in a month itself, we are able to see something like 20 times, or 4 times the entire country. 4 times the entire country in a month, and 12 times in a year gives us rich data access, which allows us to see seasonal data like Kharif and Rabi. Rabi is a dry season. Kharif is post-monsoon season. So what's the result of agricultural activity soon after the monsoon? And what is the other season, the kind of cropping that happens? So you can see the spatial domain, which normally we don't visualize this. Cropping is a regular exercise that goes on in the country. But if you want to visualize how the cropping goes on with respect to Kharif crop, Rabi crop, the summer crop, the double, and those regions where you have double crops, irrigated areas, non-irrigated areas, dry land areas, you can categorize them, and it becomes very, very important for the country to know the greenery and the produce of the agricultural activities, which helps the country in a very big way. That takes us straight away into the crop production estimation. Yes, we can not only monitor the crops, we can also see how much amount of crops are grown, what kind of crops are grown. For example, we are able to see 25 different types of crop, including the horticultural crop in the country every year. We are able to produce information, both Kharif, Rabi and summer season, to the government 1 month before the harvest. What is the amount of wheat? What is the amount of paddy? What is the amount of oil seeds? What is the amount of different other crops like jowar and others in different seasons? So country knows well in advance what is going to be our agricultural produce. This helps in a big way for export and import related decision making for the government, because we very well know the kind of development from the spatial domain and also from high resolution data, the kind of crops that we are able to grow. This helps us in a big way. Of course, there are 8 crops in a nutshell with respect to agricultural, but when you come into the horticulture, a lot more crops get added onto the system. So there is an operational system in the country which monitors the crop production estimation and also looks at the food grains in the country. On the water resources front, we have a water resources information system, which is a very enormous database on water at national level, which has more than 12 different types of information system, which works for the entire country with almost 100 years of hydrometeorological data. And this entire data is being used by the Water Resources Ministry, the base data and the various other inputs what we provide. And all these comes from both space and ground put together. And this gives a vital information for monitoring and management of water resources in our country. Himalayan region is very important for us to get into water, particularly hydrology. It produces a lot of water in the dry season, that is in the summer, when the snow melt runoff takes place. That means many of these rivers do get water from the runoff, and that feeds into a lot of irrigation systems. So we do something called as hydroinformatics. These products are very, very useful for the ground people, the way they monitor the soil and the crops and the moisture. In addition to that, we give flood early warning system and also real-time decision making with respect to irrigation water. We come out with some vital parameters like runoff and also evapotranspiration, because during the sunny seasons, we need to understand what is the activity of the sun and how much amount of evapotranspiration is happening, which also helps us in weather parameters and weather predictions. We have been making these at state level also. Water resources information system is made very interestingly for Telangana government. They use it for minor irrigation, river basin studies, and also monitoring their major irrigation projects and also minor evaluations of irrigation. In fact, they have literally geotagged all their water bodies. You can see more than 45,000 water bodies exist in Telangana, and every water body is being monitored. The tank commands are being delineated. Wherever possible, we have been able to even extend cadastral level, parcel level information. That means depending on the water, how much amount of water can be released to the farmers so that irrigation can take place, can be dynamically seen by this kind of information system. So you can literally see how from space you are able to literally reach out to parcels on the ground where we reach out to the farmers and their irrigation requirements. We just don't stop at surface agriculture or surface water. We get into inside the ground also. This is called as groundwater exploration and recharge project, which we did it for the entire country. We have entire country's groundwater maps made available to the ministries and also to the states, so that those areas where you have problem of water, you can always tap into the ground and you can use it. But our groundwater also gives you information about recharge, so that people can put back the water by creating proper structures. We use geology, geomorphology, and also the existing structural information to predict the exact possibility of quantum of water in the ground, so that it can be tapped for various developmental activity. It's a vital information and data the government uses. Recently, Jal Shakthi program was launched just before we got into COVID situation. And just before the monsoon onset, we wanted to see how we can take advantage of the monsoon by creating huge amount of water bodies. This was a new program launched by the Water Resources Ministry, and we provided a lot of help from our databases to the government by highlighting those areas where you can go for recharge pits, so that the monsoon data, so the monsoon period, the water that pours down from the skies can be utilized for storage as well as for putting it into the ground, restoring your groundwater so that it serves the purpose of irrigation in the next season. So this is called as a Jal Shakthi Abyaan, which was launched, and data analysis for intervention was completely provided from our side, which helped in a big way for the ministry. We look at the biodiversity in a big way because we are able to map our landscapes in a meaningful way. Every 2 years, we are able to bring out the vegetation map of the country. What do we mean by this? This is nothing but the forest of our country. The entire forest mapping takes place every 2 years. The Forest Survey of India does it. We have been able to give them the technology of doing it. They use the satellite data. An entire state of the Indian forests map comes out every 2 years. But we also take one more step from there. It's possible for you to get into the analysis of biodiversity also. That means how diverse is our vegetation, how well it can be used for medicinal value, how well it can be conserved, which are the areas with priority you need to conserve, can be analyzed from this kind of databases. These kind of databases have also been prepared and made available to the government, which helps us in getting huge amount of species database to be integrated with the forest data, helps in various ground measures with respect to conserving the biodiversity, at the same time addressing the medicinal value, and also conserving and preserving the rich biodiverse climatic conditions. Particularly the Western Ghats has some very rare and endangered species which need to be conserved. On the watershed front, this is another new area which India has been looking at it in a big way. In fact, Karnataka has been paving the way for this particular area. How do we involve the people in participatory mode to see that the village water resources and soil resources are preserved, conserved, and used for better agricultural produce? We came out with a new mechanism under Sujala project for Government of Karnataka, wherein we used the soil, the slopes, the geomorphology, the water resources, the cadastral data, the drainage, you name the layer of data that is required. We literally made them all, integrated them in a GIS format for a particular terrain, got into the cadastral level where even farmer will be able to address, and then came out with an action plan for every watershed, which involves villages to participate. A typical example of a Rangoli diagram you can see here, the cadastre is drawn on the ground. The people participate and tell what exactly the problem they face. We use satellite data, bring in additional information to see to that we give them mechanism by which they can conserve the soil, conserve the water, and go for a great produce. When they really do this for, let us say, 2 to 3 years, the whole scenario on the ground changes. You can see the positive impact of a before treatment and after treatment satellite data, what you see. Over a period of 5 years in Kolar itself, we were able to see a dry patch. You are able to see, in fact, a very, very dry patch, a gully terrain has completely changed into a good agricultural patch. You can see similar kind of activity happening here, which was pretty dry. And here you can see a highly degraded patch coming back into agriculture. You can see there were no foreshore plantations that have come up, which increases your water body depth and also information, so additional water availability for the surrounding crops. So the whole scenario changes. You change the health of the soil, you change the health of the condition of the people and various other aspects. So there is a cascading mechanism by which you can positively use the watershed development program, which has been demonstrated by Karnataka. In fact, Karnataka is a leader in watershed development, and the entire country follows this mechanism elsewhere also. For example, using the Karnataka model, we could also develop soil and water conservation mechanism for the entire country. We are monitoring 86,000 watersheds for Ministry of Rural Development under the similar kind of a scheme, but we have brought in the mechanism of monitoring through mobile applications also. We can very clearly see before and after scenario here, wherein you are able to see a lot of water ponds from the degraded land. We are able to develop it and convert the land into a lush green vegetation area. And these are typically the geotagged pictures where we monitor both from satellite imaging as well as by GPS based mechanisms. Since I was telling you that the satellite revisits very frequently, it is possible for you to literally watch every water body from space. Any water body which is 2.5 hectares, you are able to see from space, and you can see the dryness or the wetness. You can watch the reservoir from space continuously. Depending on the water levels, you will be able to release water to the farmers. At the same time, the conservation measures and control measures can be adopted. So government uses these kind of systems very effectively for the entire country. So every 15 days, we are able to get a water body map of this kind for the entire country at 2.5 hectares as kind of a sizing, so that the country gets benefit of monitoring the water body even at village level. A typical example of how Bangalore and its water body looks like from space. We have been able to literally categorize and track water bodies from space, and you can track these on our Bhuvan web geoportal, which is a cloud system, a cloud platform, which enables us to not just look at the ground, but start looking at vital parameters like water, soil, agriculture, crops, vegetation. You name the surface parameter, you name the groundwater parameter, kind of a thing you can see from space. We also help the government in planning urban areas. Of course, Indian cities are pretty crowded. Bangalore itself is a typical example of how crowded it is and the kind of traffic problems what we have. But if you want to really plan your cities well and develop them, a 4,000 scale, that means a very high resolution, sub-centimeter level, meter level resolution, like 1:4,000 scale, enables you to literally look at every housetop, every tree, and then make a very detailed plan like what you see on the right hand side, and you can improve the quality of planning, quality of implementation, and improve the urban areas much better. We are talking about city planning, township planning. We are also talking about smart cities. Amrut is one typical program of the government of India, which has been utilizing this particular data, and even smart cities has been utilizing this particular data. But if you look at the time series data, it is possible for us to look at the Bangalore itself. Since we are mostly Bangaloreans here listening to my talk, I thought I can show 1 or 2 slides on Bangalore. The urban areas of Bangalore in 65, in early 70s, were something like this when we were mapping from that side, even though metropolitan area was much larger. But slowly over a period of time, I think we are sort of overtaking Bangalore metropolitan area, and we are literally crowding up. You can see how things are changing. Obviously, urbanization has to grow, no doubt about it, but not at the cost of environment. We need to preserve our environment by retaining the water bodies, retaining the vegetation, and retaining that kind of airspace which is required for us. A typical example is seen here, even from if you continue from previous 1965 kind of data, you have 96 data, 2002 data, 2013 data, and we are coming to the recent data sets also. We have literally been, in fact, one of the largest urbanization pattern seen in the Asian countries is possibly Bangalore, one of the leading urbanization area. So what I'm trying to highlight here is urban sprawl management and monitoring is possible from space. Government has to more meaningfully use this particular data so that we are able to come out with counter magnet townships, develop adjacent townships so that we don't overcrowd in a given area. That's what is the lesson we need to understand from this, because we have overcrowded this whole area. The metropolitan which was drawn before is overshadowed, and what is the result of that? We end up polluting. For example, 70s Belandur tank looks clean and neat. You can see the drainage very clearly, the moist area, but you can see now literally it is choked up. You can see a water body which is almost disjoint from the Belandur tank. That means the flow of water is cut down because of massive urbanization that has taken place along this particular river. So you can easily analyze such things. At least even now, if we can do this kind of time series analysis, we can try to improve our conditions. But I am trying to take you into a different area altogether. We need to use Earth observation data analytics using the complex real world problem solutions. That means you need to get into the machine learning and deep learning techniques of our artificial intelligence. We need to bring in fact, a lot of youngsters may be watching this. I want you to become active. I want you to use some of these techniques with the kind of data ISRO has and bring in big data analytics in a big way, bring in artificial intelligence in a big way, and see that we build IoT based tools and technologies that can be helped to see that our planners and our decision makers at top level get real-time information with respect to the quality of life on the ground, and we can improve the situation on the ground. There is a big requirement for us to take more complex real-life problems and solve it using Earth observation satellite data and bring in a lot of these techniques. We are already doing it. Many of our tools and technologies are already working. Deep learning, we have been able to bring in onto, let us say, water body mapping, onto the agricultural mapping, onto the intelligence that you need to do by hyperparameter tuning technologies, which we are bringing in to the system, because process flow demands that kind of tuning, so that you can continuously do the classification of satellite images by using more complex phenomena. And here we need a lot of youngsters to chip in with their bright ideas. And I'll take you to another region where we are talking about green energy today. Energy management is an important thing, and space helps in a big way to understand how much amount of solar energy can be tapped from the rooftop. Every house rooftop has tremendous potential to provide energy. That's what these pictures on the left-hand side says. We have come out with an interesting tool on the mobile through a mobile app. You can use this app. If you have a mobile app, you can download this app. You can go onto the top of your house, find out how much amount of energy can be tapped across the year and what we are doing. If we are not having a solar energy tapping system on the top of our house, we are actually wasting a lot of green energy that is freely available. So I encourage one to use our apps. In fact, we compute the solar insolation from INSAT series of satellites, and we are able to exactly predict how much amount of solar energy is possible from the top. We have an interesting platform called as Bhuvan. Bhuvan is the engine, which is a cloud-based engine, which has tremendous user base today, which provides 1 meter resolution. It works in 2D and 3D. It gives you enormous amount of information, both through mobile apps as well as through online query system. And all the things what I talked about so far, all that it gets reflected in Bhuvan. And Bhuvan, I want a lot of youngsters to join in and work with us, ISRO people. For example, we have an excellent visualization platform. We have a interesting free data clearinghouse. People can download satellite data from here. We have an interesting platform for building newer applications. A lot of startups and youngsters can join us in building newer and newer applications for developmental purposes. We can, in fact, we use this particular platform for disaster support too. And also we have state-wise databases. All the states are participants of our Bhuvan portal, and we use this particular portal for mapping applications. We use it for varieties of other digital and knowledge intelligence. This is an example of how MGNREGA, this is Employment Generation Program of the country, which India spends a lot of money in the rural areas. We are able to track on this particular applications, the kind of assets what the rural poor are able to create and earn money. In fact, we are able to map more than 4 crore assets that has been created in the rural area, like check dams, nala bunds. It could be bund stabilization. It could be community halls in the villages and things like that. So rural India uses the MGNREGA program and uses our Bhuvan platform in a very big way for varieties of developmental pattern. And we do some kind of a monitoring from space for the government to see how well the program is running. Many of us use the mobile app. I'll show you a couple of interesting mobile apps which we work on in addition to the other applications what we do from space. Very quickly, I'll finish it so that I will not be spending too much amount of time because I was stipulated 45 minutes. I want to see whether I can live within that time. We all know that accelerometer is one of the interesting sensors available on our mobile. So you can use GPS that is available on the mobile, which is again from space, and the accelerometer to find out the quality of roads what we have in urban areas. Easily you can map. In fact, this has been done in one of the Maharashtra districts, one of the townships. We did it in NavIC, for example. It allows you to map the green roads that are good, the blue roads that are semi-good, and red roads that are pretty bad. So bad roads can be mapped, and the government can use this information to correct those and monitor again from space to see that these roads are repaired. So government gets information about which are the bad roads from the accelerometer and GPS that is available on the mobile. And this app just need to be mounted on a car, and you drive the car in various roads in different days. And the accelerometer data, depending on the thresholding what we have done in the system, gives you the information. You can also do online geotagging. It does continuous geotagging and produces maps of this kind. So many things happen from this particular application. You can map all your roads. You can map all the condition of your roads, and the government can be given a charge saying that these are the roads which are bad, please repair them. So many good things can happen from such kind of applications. And I encourage youngsters to get into such kind of applications, which is innovative in nature. Not only that, we also talk about many museums in the country today. Mostly people are working from home. If you want to get into Salarjung Museum in Hyderabad, I can take you inside straight away, because we do something like 360-degree mapping from a GPS held mobile tool, and you can possibly visit your museums and then start looking at it. So we use GPS, we use the mobile tools, and we use special cameras to see that we give you a 360-degree view of a museum, for example, or a planetarium, or any other important, interesting place which you want to visit, you are not able to visit, but it allows you to do that. You can develop such kind of technologies today. For fishermen, we have developed a very interesting mobile app, which not only allows him to carry a mobile, it also helps him in the deep sea. For example, mobiles work until say 10 kilometers from the seashore, but once you get deeper into the sea, you will not get any SIM that is working on your mobile. So only thing that supports you is NavIC, that is our Constellation. It helps you. I forgot to tell you, NavIC is a very unique tool which also does messaging for you from space. That means from ground you can do messaging to a fisherman who is deep into the sea. So we have developed a mobile app which gives information to the fishermen on the fish catch, exactly where you get the fish catch. So using the map, one can navigate to that particular point. And once you are there, this is a particular app on the right hand side, what you're seeing, you will get location based information on exactly what is your location in the sea, because you know very well when you're deep into the sea, you're all at sea. You don't know where you are unless you have a very good app in your hand. So it gives you the location. It also tells us about the maritime international boundary, which you're not supposed to cross. You may be arrested. Many of our fishermen get arrested in the sea because they have crossed over to the other side, crossed over to the other international waters. It gives you online information about potential fishing zone, which the users can use. It gives you the weather state and the sea state, which helps the fishermen advance information to quickly come back in case there is a weather decay that is happening. And of course, it is a multi-language support platform. This is a very unique rural application because millions of people live in the coastal areas of India, and we need these kind of applications, which we have developed and given it to the fishermen community today. And it helps NavIC to be used in a big way for these users. On the disaster management front, ISRO helps the country in floods, in cyclones, in forest fires, in various other activity. If you carefully watch the kind of disasters that has been striking India from 2013 onwards, I'm able to see a good kind of a pattern that is emerging. Of course, a typical example of what happened to the Kedarnath and the surroundings in one of those disasters in 2014, which caused a huge damage, not only on the ground, but the people's life. So we map the cyclone very effectively, and also the floods from space. You can typically see the cyclogenesis, which is a typical example of the process. We are able to see and track the cyclone, and we are able to exactly predict the intensity and the landfall of the cyclone because of the storm surge. And the warning helps all our civil servants to act in the coastal area and take the people to the safer places. This technology has helped us in saving a lot of lives today, which IMT does it very, very effectively. And at the same time, we are able to assess the impact of the disaster soon it strikes on the ground. We use these techniques particularly when incessant rains are there, which we saw in Kerala. We were able to see the flooded areas in Kerala just when it happened in 2018. And in fact, on our portal, you are able to literally watch this particular data. You can see on the left-hand side, almost per day, 2-3 data sets from space were brought in, and the data was put into the system to see the kind of increase in flooding. As you can see, the blue pattern, the way it increases and it starts inundating the area, and those areas where the water is stagnant over a period of time can be seen in the near real time, which helps the government to prioritize the disaster management in the near real time. This is what is the advantage of giving real-time information with respect to the flood kind of disasters, which ISRO provides quite effectively to the flood-affected areas all across the country. I think with that, I would like to stop. We will soon look at Gaganyaan, which is going to be Indian first human space flight program. ISRO is working very actively on that. And this is a typical picture of Chandrayaan-2. I thought towards the end, I'll show you one typical image. A lot of image processing is possible on moon surface. In fact, moon and Mars data is put out in the public domain, which people can download and use it for varieties of image processing tools and technologies. You can do a lot of new findings also. So with that, I would like to close my talk. Thank you very much again for giving this opportunity.
Thank you, sir. And I'm sure the amount of time that you talk is not sufficient for us. The time just flew as it is, and we need more information from you. Sir, I'd like to take a few questions which has been posted.
Yeah.
Shall we go ahead? The first question was posted by Dr. Vijay about showing images, but I think you have shown a few of it. Dr. Vijay, if you have any more specific images you are looking for, please let us know. The second question is from Mr. Hariharan. Why is NavIC not used as default navigation in Indian phones?
Yeah, it takes some time because the country has already got used to the GPS on most of the mobiles. NavIC Constellation has recently come into the picture. But days are not far. Most of the mobile manufacturers are incorporating NavIC into their mobile apps because most of the people use the GPS on their mobiles. Very soon you will start seeing the chipsets of NavIC integrated into the mobile, and once that is there, then slowly the government can start bringing in a mechanism by which NavIC can become default. But it takes some time for you to switch over from GPS to NavIC. But NavIC's performance is excellent, on par with any others in the world.
Thank you, sir. The next question from Dr. Srinivas. What determines the life of a satellite in its orbit? What are the hazards of a satellite losing the orbit and falling apart?
Of course, satellite, the main thing is fuel. We need to ensure that fuel is well conserved, and as you might have seen, most of our satellites are very accurately launched. Our launch vehicles are so precise. We are able to put our satellites on the dot, almost just a few kilometers away from the planned orbits. Once we do this, we are conserving the fuel on board, which is used for the 3-axis stabilization of the satellites, which we use this fuel. But once the fuel gets completely over, obviously you will no longer be able to maintain these satellites in the 3-axis. So slowly the decay in the orbit sets in, and you will not be able to manage the satellites, and it comes closer to the atmosphere. It means, in the sense, it decays in the orbit. That's what happens. But I would say most of our Indian satellites have survived much beyond the mission life. Normally, the polar orbits are planned for about 5 years, but most of these satellites function for 15 years almost. Cartosat-1 functioned for about 13 years. Resourcesat-1, after that we have launched Resourcesat-2 and 2A. 2 more satellites have launched, but Resourcesat-1 is still functioning, still providing data. That's the beauty of our accurate launching and functioning of our satellites. So it's all fuel ultimately.
Thank you, sir. The next question from Dr. Sanjay Chetnis. Which ISRO satellites provides data relevant to monitor various types of pollution? Do we have something better than MODIS from NASA, Terra satellite? Is the project for pollution monitoring being done with Coal India ready?
Yeah, it's a very interesting and important question. In fact, we are doing very interesting applications on air pollution and water pollution. I forgot to mention that. In fact, there are a lot more applications which I would have covered, but 45 minutes is not enough. So I just picked up a few which easily gets into all the people. Air pollution and water pollution is being used, and MODIS is one of the typical satellites that provides a lot of products. Is right. We do use MODIS, but in addition to that, it is possible for us to use INSAT. INSAT 3D and 3DR are the third generation satellites which is up in space, providing data on a daily basis. In fact, every 15 minutes we get INSAT 3D and 3DR satellite data. We are able to use that, but we need to improve upon the sensors and launch more satellites which will specifically look at the air pollution parameters. It will happen quite soon, but certainly INSAT is able to provide a good amount of information on pollution. Yeah.
Thank you, sir. Again, another question by Dr. Sanjay Chetnis. Are we also working on quantum communication on the lines of China's MICS satellite?
Very much. ISRO is very much working on that. The team is working on that, and certainly sometime soon we will be hearing about the quantum communication related activities and up in space also. Yeah, we are working on that. Yes, very much.
Next question is from Dr. Ramkumar sir, and he was requesting for a 3D view of any town. So,
I didn't get. Can you repeat?
3-dimensional view of any town. So
yeah. In fact, literally, you can look at the 3-dimensional view of any town because the stereo imaging for the entire country has been done from Cartosat-1 series of satellites. And one can go to Bhuvan and start looking at 3D of any terrain possible. Not an issue at all. If he is interested in any specific area, he can ask us, we will provide to him. Not a problem. Yeah.
Another question from Dr. Sanjay Chetnis sir. Can we have a learnathon, hands-on workshop on using Bhuvan and NavIC for our students and faculty?
Very much we can do, and maybe I would suggest Bytes can ask me and I can make one more presentation specifically on Bhuvan and NavIC, because these two are very interesting online tools which a lot of people will get enthused to use and analyze, and there is a lot of value addition possible both on Bhuvan as well as the NavIC based tools. Yes, I am very much for it. I request Professor Murthy sometime he can come back, and again we can do it once more from the Bytes. Yes.
Another question, they are asking if there is any time gap or a time delay between the two images that is captured of same spot. Will it be like 5 days, or I mean, will it affect any kind of image analysis?
Yeah, see, this depends on, it varies from satellite to satellite. I talked about advanced wide field sensor, which gives you every 5 days imaging because it covers a large swath of 740 kilometers. But it will not be so. For example, if I take list3 data comes back to the same spot every 24 days. But using, for example, if I want to revisit a particular place every day, I need more number of satellites. For example, AWIPS kind of satellite. If I am able to put 2 satellites, from 5 days, I can come down to 2.5 days, let us say, just for mathematical purposes. So if I put 3 satellites of ResourceSat, possibly I'll be able to approach closer to everyday imaging. So in fact, today we have ResourceSat 2 and 2A, and ResourceSat 1 is also functioning. If you take all the 3 images, almost every day you will be able to see a particular area of 740 by 740 kilometers. Yeah, it is possible. So ultimately, the answer to his question is, depending on the resolution, depending on the altitude, it is the number of satellites that decides on how many, means how you can revisit. For example, today Planet Labs has, I think, some 200 or 400 satellites in space. They can see entire globe every day at 3-meter resolution. So it's number of satellites ultimately.
Thank you, sir. Another question from Dr. Ramkumar. This is with respect to town planning. It will be helpful for flood evaluation when we faced what we faced in recent days. If there is three-dimensional view of building of town, what is the procedure to get this?
Yeah, there are 2-3 things one need to do. This is an interesting question again. It is basically urban flooding, what is being talked about. You need to have a bare earth digital elevation model first. That means, for example, before the building was constructed, what was the terrain looking like? One need to know, because ultimately water flows on the ground. So one need to know what was that. And over a period of time, the terrain has changed. A lot of buildings have come. You might have put some roads. You might have brought in new elevations. So you need to look at the 3D city models. That means you need to have a terrain model, and you need to wrap a 3D city model on the top of the terrain. Then you can simulate the flood. Everything can be done on the computer. Everything can be nicely organized on a computer. And it is a new challenge for youngsters to simulate such kind of things, and it can be easily done. But certainly ISRO can be part of that kind of an activity. I can guide them, and they can certainly do it. Yes, very much possible.
Thank you, sir. The another question is from Mr. Vinayak. Can the behavior of tectonic plates and seismic waves can be analyzed by high-resolution satellites?
Seismic is very difficult. You need to have sensors on the ground, because that's what BARC does it. That means Baba Atomic Research has its own sensors. In fact, in Gauribidnor, we have a seismology center in Karnataka. They get excellent data. In fact, the person can visit there and he will get real information about what a seismology center is all about. Tectonics is something which can be talked about from the geological perspective by using the space data. You don't need to be seeing very high resolution satellite data for tectonics. You can see even with coarse resolution, fairly a good amount of information on geology structure can be integrated to understand the tectonics. But tectonic waves is a different story altogether. It will be difficult again. Yeah.
Thank you, sir. Doctor, next question is from Dr. Reja. Is there any technique for the spacecraft jitter to improve the geometric performance of satellite images?
Yeah, I think it's a very important question. I talked about the three-axis stabilization. Any satellite which is up in space is in 3-axis, pitch, roll, and yaw, what we call. These 3 parameters need to be very accurately monitored. Then only the jitter can be controlled. If the jitter is well controlled, it will have direct impact on the planimetry by which the imaging takes place. See, it is very clear. For example, if you are holding a camera and taking a photograph of somebody, but if you are not holding the camera properly, then if you are holding tilted or if you are moving, etc., then obviously your image quality will change. Similarly, if the object is moving, it can have the same impact. But here, you can't control the object. Earth is anyway moving. But you have to have a very good 3-axis control of your satellite so that jitter is in control. And jitter control helps you to have a very stable platform. And once you have a stable platform up there, you will be able to have very good planimetric accuracy in your satellites. And most of our Earth observation satellites of ISRO have excellent planimetric accuracy. We are within 1 pixel accuracy of our outputs, what we provide, the geometric accuracy.
That's nice, sir. And the next question is from Dr. Radhika. Please enlighten us on how different satellites are used, especially during the tough situations at LOC, that is left of Jammu and Kashmir, and LAC, right of Jammu and Kashmir. How the different satellites can help our soldiers at points of high altitude?
Basically, this question is on the strategic side. But my talk was completely on the civilian side, and strategic side, normally we don't address it in the public domain. So I would like to restrict myself from answering this question, except that high resolution satellites can be very effectively used in the borders. Every country uses it. India also uses that.
Another question from Dr. Ramkumar. Can you suggest some student projects? What is the procedure for involving the projects?
Student projects can certainly be done. There is no problem at all. Normally the student projects, people have to write to the respective directors of the centers. If, for example, you are interested in doing something related to satellite, electronics, and things like that, then one need to go for our URSC, that is URRAO Satellite Center. You will be able to send an application there by giving a project proposal on what you want to do with respect to satellites. If somebody is interested in propulsion and something with respect to spacecraft, then one need to approach the director of the Vikram Sarabhai Space Center, so that you will be able to, a lot of mechanical engineering, chemical engineering related projects can be done there. On the application front, of course, people can approach me also, or one can approach the National Remote Sensing Center or the Space Application Center. They deal with a lot of tools and technology development, particularly computer science people, civil engineering people. They can do application projects in a big way. So different centers in ISRO deal with, because they are all specialized. Each one of these areas are specialized activities. So the centers deal with these activities separately, and they need to approach respective centers for doing any project. But I can guide them. That is certainly possible.
Thank you, sir. The next question is from Dr. M.K. Banga. How does ISRO ensure the safety of our satellites, especially in the presence of ASAT missiles with a few countries?
Again, see, I can answer these questions, there is no problem. But see, these are again getting into the strategic area. I would like to restrict myself in the civilian domain, because normally defense related, strategic related, we normally don't address it in such public forums. So I would like to refrain myself from answering this question also. But our satellites are safe, no issue. We have all the necessary protection mechanisms and safeguards built in all these satellites and ground systems. And ISRO is pretty capable of that, not a problem, no issues.
There is another question from a student. Can we apply for internship at ISRO for 8th semester by Supriya?
See, the only problem with internship is you spend very, very little time with ISRO, and by the time you get adjusted with ISRO, your time is over. That is the problem. If somebody would like to do a 2-month, 3-month kind of a project, ISRO would be welcoming them and certainly put you into give you a tough job which you will not be able to easily complete. You have to really burn midnight oil to complete those jobs. So it will be challenging to work in ISRO, especially as a student project. But internships, only in very special cases it is taken, not always. In fact, internships are difficult in ISRO, because even we can't spend much time, and internship needs some amount of time spending that has to happen. And if you don't spend time, the student gets dejected, saying that, see, these guys are not helping me, etc. We don't want to get into such situation. ISRO is very, very sensitive on such matter. So we encourage more of student projects rather than internships. But certainly we encourage innovative ideas as internship, and we can certainly look at it case to case basis. Like that's how we deal with it.
Yeah, thank you, sir. And then the last question from student Shubhangi. Why don't the fishermen use the communication system for the Indian Navy? How is NavIC more helpful? I think you have told that.
Yeah, actually, see, there are millions of fishermen out in the sea, and if you start giving them communication system, it will be a costly affair. Instead, they already have a mobile. All we need to give them is a small device on their boat, fixed onto the boat, that is NavIC, and put a mobile app onto their on their mobile, and they get all the necessary information, even if they are 100 kilometers into the sea, because messaging service is working. So if there is a disaster, they will come to know. If there is a very good fish catch in a particular neighborhood, they will come to know. If they are crossing over the international waters, they will be alerted. There is voice messaging also possible. So we have built very interesting application, and it can go into masses. That means millions of fishermen can simultaneously use these apps and the devices at a cheaper cost than going for a communication system, which is costly affair. That's how the trade-off comes. So it's always good to use NavIC than the other one. Yeah.
Thank you, sir. And another question from Supriya. how to join as an astronaut in ISRO and what are the requirements?
That's a very good aspiration. I would love to have a large number of youngsters joining ISRO to be astronauts. Of course, you need to train yourself very hard right from now. It's not easy. And the kind of rigorous training that an astronaut goes through, it can't be explained even in 1 hour time period on a presentation like this. In fact, as you very well know, the Indian Air Force selected people have gone to Russia, got trained and come back. And that kind of people of course, there's a big selection process. Even to get selected as an astronaut, even from the Indian Air Force, a lot of people would have initially participated. Ultimately, 3 or 4 people get selected. Out of that, a couple of people will go really into space. It's not easy. In the sense, the kind of rigor that is required for preparation is enormous, but nothing is impossible. If one has a willpower to do that, train yourself from now, become an Air Force pilot, and I'm sure one fine day you will be able to fly in one of our spacecrafts to the space. Why only to the space? You can go into the heavenly bodies one day, not a problem at all. Yeah.
Thank you, sir. And another question from Shri's student. How is NavIC going to change GPS technology worldwide?
NavIC is a regional system, as I told. So it covers India and a whole lot of neighborhood. And ours is a very interesting system, accurate system, comparable to any other GPS in the world. So it is a regional navigation system which can give a lot of indigenous applications. Assume that we have switched over to NavIC tomorrow. Entire data of your location is within the country. Today, we are using GPS, let us say from Google platform. Google is the map. You use GPS, which belongs to some other country. So what exactly is happening is all your location information is elsewhere. It's going elsewhere. But once you have NavIC and you are exclusively using NavIC, it means the security part of it will be well taken care of, because all the data will reside in India. Of course, there's going to be a whole lot of other applications that is being driven today. All your Uber, Ola kind of applications can be indigenous. A lot of startups can develop applications for Indian consumption within India. You can have a whole lot of rural and urban applications. All the school kids can have the NavIC-based tools and technologies used for their schools. Even to go to school and come back, you can track them. So a whole lot of game-changing mechanisms can be brought in with the kind of applications that can be built from NavIC once NavIC becomes completely used in the country and once we are away from other GPSs.
Thank you, sir. Another question from Mr. Shyam Sundar. What requirements for aerospace engineering ISRO?
I didn't get requirement.
Requirements for aerospace engineer in ISRO.
Aerospace engineers are very much required in ISRO, obviously, because aerospace is one key area which one uses. Avionics, aerospace, we do deal with it. Even our Indian Institute of Space Science and Technology deals with aerospace as one of the subjects where MTech, BTech and MTech is being taught. A lot of students are doing those courses and they join ISRO. The high-ranking people join ISRO, contribute to ISRO in a big way. So there is a huge demand for aerospace, aerospace qualified engineers in ISRO, and we do have good number of them, but there will be always requirement for aerospace, no doubt about it. And not only here, even abroad, there are huge opportunities elsewhere also, not only in India and ISRO, even elsewhere. Yeah.
Next question from Shiva Vallabha. Does ISRO have ever tried to build a reusable rocket?
I think a lot of news is there on that. If you carefully see, very soon, you should be watching now, very soon we are going to demonstrate the reusable launch vehicle. A few tests have taken place already. We have successfully gone through those tests, which was demonstrated pretty well. Already one test has taken place. One major test is going to take place. So we are very much with building this technology. We have been working on it for some time and we have reached fairly a good stage of maturity. But our understanding and our way of reusable launch vehicle is much different from other countries. You will be watching it very soon.
Another question from Ms. Supriya. Is it necessary to be an IAF pilot only? Any other way to join astronaut program?
IAF is most preferred because there are a lot of parameters that is satisfied because a pilot flies the engine for quite a good number of hours. He would have experienced many types of jitters, many types of, for example, you need to get into zero gravity kind of a situation, which needs special training. So without such kind of experiences, if you want to really get into a zero gravity kind of an experience, it is slightly difficult, obviously. It is a plus point for one to be a pilot. That's what my knowledge says. But of course, that doesn't stop even from a school teacher to go to space. Even a school teacher has gone to space. Even other civilians have gone to space. Going to space is one thing, but going as a cosmonaut or an astronaut to function there, to work there, to deliver, to do experiments is much different. There's a difference.
Thank you, sir. And there are many more questions actually, but looking at time
constraint,
you have talked to us for quite a long time. So I think surely our VC sir will call you once more. We need a talk. Sir, thanks so much, Dr. P.G. Divakar, for answering the questions and sharing your vast knowledge with us. It was a pleasure to have you with us. Now I request our revered chair, our revered Dr. K.N.B. Murthy, Chairman, Vice and Vice Chancellor, Dayanand Sagar University, to propose the vote of thanks. Up to you, sir.
Thank you. Thank you very much. Yeah.
Good morning, sir.
Thank you, sir.
Thank you for accepting our invitation to be here to deliver this talk. It was quite interesting. There are lots of questions. The number of questions more or less speak the acceptability of the talk. And there are also a good number of requests for you to consider delivering one more talk. And probably it will go on. Thank you very much. I think I'm extremely happy to inform all the audience that Dr. P.G. Divakar is one of our esteemed board members of BITES. And above all, he is a great human being, very simple person. You can approach him. I think one of the qualities of a great human being. And this particular thing, it's with the greatest difficulty. I think I could get his time because he's very busy with a lot of other activities. We are extremely thankful to Dr. P.G. Divakar. And I will follow up for the next lecture, sir. I think please.
Sure. Thank you. Most welcome.
I request you to consider that probably the NavIC and the other one would be the right kind of topic. Probably with a lot of demand there.
Yeah.
Thank you. Thank you very much.
Thank you.
I think we will meet you very soon for the second lecture. Thank you. Thank you.
Thank you. Thank you so much, sir. Thank you very much.
I also take this opportunity to thank the Dean of School of Engineering, the Registrar, for hosting this lecture at Dayanand Sagar University. And also thank Mr. Imtiaz, who has done all the facilitation for this virtual lecture to happen. Also thank each of the faculty members who are involved and helped us to conduct this lecture. Thank you. Thank you very much.
Thanks a lot, sir. Thanks a lot.
Thank you, sir. Yeah.
Thank you, sir. Thank you so much. So this concludes the webinar. Thank you all for attending. We hope all have learned and enjoyed this session. Have a nice day. Thank you.
Thank you. Thank you very much.